Pre-medical presentation brought to you by the Lusaka Apex Medical University Faculty of Pre-Medical Sciences. Today is a special presentation. It's a mathematics presentation entitled Sets and Statistics in Real Life. I would like to acknowledge the presence of our professorial team. Members consist of Professor Mwaba, Professor Lambert, Professor Jelasani, Professor Mudenda, Professor Emaus, Professor Molenga, Professor Monsa, as well as Professor Kasonga, Professor Kumar, Professor Golani, and many others, such as Professor Biemba and many more. I would like to also acknowledge the presence of our Dean Faculty for Medical Sciences, Dr. Chira, who is our moderator for today, and I'm your host, Madam Shinondo, here as part of corporate communications. Without any further ado, I would like to invite our moderator, Dr. Chira, to briefly introduce the topic and begin the presentation. Dr. Chira, the floor is yours.
Okay, thank you very much. Good afternoon, everyone. Good afternoon to our lovely presenters. And good afternoon, Madam Kateka. I see you are there physically with the students. I've seen Mr. Mkosa online as well. He's a little bit under the weather today, but he has still managed to be with us. We really appreciate that. I don't know if Professor Lambert is in the office or not. Okay, so today's topic, just like any other topic, is coming from the curriculum. I've seen that the topic encompasses both 1,1 students and 1,2 students. So whatever we are talking about today is from the curriculum and it is examinable. I can assure you that you are going to find examination questions on sets and examination questions in statistics. People are here to learn about medicine, pharmacy, nursing, nutrition and dietetics, biology, and all the other courses that we offer. How does mathematics come in? Do medical students really need mathematics? Do they need sets and statistics? So our presenters are going to show us how that applies to everyday life, including medicine and the other courses that we are offering. So I'd urge our participants to pay much attention, take down everything. At the end of the day, we may be given some questions. So generally use this for your revision. Over to the participants. Unless if the lecturer wants to say one or two things before we start. Madam Kateka or Mr. Mkoso? If not, then we can go direct into the presentation. Let me try to get hold of Professor Lambert.
Okay, writing on the protocols that have already been said. Good afternoon, everyone. My name is Tatanda Kauta Sakura. I'm from Pre-Med 1-2. We will take you through our mathematics presentation, sets and statistics in real life. Okay, so before I begin, allow me to start with the thoughts. Mathematics is the language of the universe. It is the silent reading behind how we think, organize, and make decisions every day, whether we realize it or not. Today, we would like to take you on a short but fascinating journey.
Oh, okay.
And
we have the gun round. Okay, thank you. Okay.
Okay, my apologies. Today, we would like to take you on a very short but fascinating journey into two of its most powerful tools that has already been said, sets and statistics in real life. We'll talk about how these two shape the world around us. At first, allow me to start with sets. The idea just seems so simple. A set is a collection of objects that share something in common. But if we're to look a bit closer, this concept is everywhere. Doctors, they use sets when they group patients according to their symptoms, age group, blood group type, or test results. And pharmacists, they also classify drugs based on their chemical properties, the diseases that they treat. We also use sets in our daily lives. Whenever we separate fruits from vegetables, even when we're doing our laundry, we use sets when we separate clothes by color, when we put the white clothes on their own, the dark colored clothes on their own, those are sets in action. Sets help us to bring order to complexity. They allow us to see patterns, connections, and to reason logically about relationships between things. So now allow me to move into statistics, the beating heart of data-driven decision-making. Statistics, it transforms numbers into stories. It helps us to interpret the world instead of just observing it. In healthcare, for instance, just imagine you were a doctor and you're deciding between two treatments. Without stats, obviously you will guess. But with statistics, you know which one has better outcomes, cost efficient, and there's fewer side effects. In business, statistics, it helps companies to understand customer behavior and forecast trends. In governments, they shape policies, budgets, and national planning. In our personal lives, we also rely on statistics whenever we check the weather forecast, compare prices, or read about the probability of passing an exam. So what makes statistics powerful is that it doesn't just collect information, but it reveals the truth through patterns and probability. It teaches us how to think critically, to question, to test, and to draw conclusions that are evidence-based rather than just assumptions. So when we combine these two, sets and statistics, we unlock even greater potential because sets, they allow us to organize data clearly, while statistics allows us to analyze it meaningfully. These together, they form the foundation of modern science, economics, and technology. They are the reason doctors can diagnose accurately, engineers can predict outcomes, and researchers can make discoveries that can save lives. So the next time you hear the word stats and statistics, especially to my colleagues, don't just think of them as dry mathematical concepts, but think of them as invisible tools that structure our world, helping us to bring clarity to chaos and truth to uncertainty. So I'll allow my colleagues to come and expound more on how assets applied, how statistics applied in real life, the examples. Thank you.
Good afternoon. My name is Iqra Ahmed, and I'm here to continue what my colleague has started. Sets. What is a set? A set is a well-defined collection of distinct objects called elements. Each element in a set is unique and it only appears once, and the entire set is treated as one complete unit. Sets are represented by capital letters and curly brackets. Examples of sets are like set A, set B, and set C. Examples of non-sets are set D and set E. Types of sets: finite set, empty set, infinite set, superset, equivalent set, and power set, also universal set. Set operations. In mathematics, sets are important because they set foundation for advanced topics such as relation, function, and probability. Set operation like union, intersection, difference, and complement, as you can see. I have an example here which reads, in a hospital, 100 patients were diagnosed with diseases as follows. 60 had malaria, 45 had pneumonia, and 40 had cholera. 10 had cholera and pneumonia, 15 had both malaria and pneumonia, 5 had malaria and cholera. 15 patients had all of the three. The question is, first, draw a Venn diagram to represent this information. B, find the number of patients who had exactly one disease. Find the number of patients who had neither cholera nor pneumonia. The answer is that this is how a Venn diagram is supposed to be drawn. As you can see, the B says find the ones who have one, which is 2510 plus 5, which will equal to 40 patients. C reads that find the ones that are not in A and B, which are not in C, cholera and pneumonia, which is 25 plus 15 equals to 40 patients. Applications of sets. First application of set is computer science. Sets help manage data structures like hash, sets, and dictionaries, used in algorithms for search, sorting, optimization. Crucial in database queries, e.g. finding common or unique entries. 2. Data analysis. Sets identify duplicates, unique values, and overlaps in data sets. Helpful in comparing surveys, results, or customer service. In healthcare facilities, doctors use sets to match symptoms to diseases, avoid dangerous drug combination, and organize patient care. It helps make better decisions and save lives. And I'm going to call my next colleague.
Good afternoon, everyone. My name is Stefana Lefelis-Timbo from the Faculty of Premedical Sciences, 1.2. I'll take you through statistics. What is statistics? Statistics is the science of collecting, organizing, interpreting, and analyzing data to make informed decisions. In statistics, we have two branches, which are descriptive, as you can see, which are descriptive statistics and inferential statistics. Descriptive statistics consists of organizing, displaying, and describing data by using tables, graphs, and summary measures. And under descriptive statistics, we have measures of central tendency, which is mean, mode, and median. And then measures of variability, we have range, variancy, standard deviation, interquartile range. On presenting the data, graphical representation, we have histogram, box plots, and pie chart. Inferential statistics consist of method that uses sample results to help make decisions and predictions about a population. Sampling methods. It's often impossible to study the entire population. Sampling helps us gather meaningful data efficiently. Under sampling methods, we have probability sampling methods and non-probability sampling methods. On probability sampling methods, we have random sampling methods, stratified sampling methods, cluster sampling method, and systematic sampling method. And then under non-probability sampling methods, we have quarter sampling, purposive sampling, snowball sampling, convenience sampling. The process of simple random sampling, we define the population. We create a sample from the population. We assign numbers to the sample. We select the sample and then we collect data. Under stratified sampling, again, we define the population. We put the population into stratas and then identify the sample. Under clustered sampling, we identify the population. We put the population into clusters. We randomly choose the clusters and we take the sample. Data organization. Why do we organize data? So that we can easily understand insights and make accurate decisions and predictions. We have methods of organizing data, frequency tables, graphs, data visualization, and stem and leaf plots. In this case, we are going to focus more on stem and leaf plots. Stem and leaf plots organizes numerical data into two parts, the stem and the leaf. Where on the stem, we have the upper digits, and on the leaf, we have the lower digits. We'll make use of this example. The following data gives the systolic blood pressure readings in millimercury measured for a sample of 30 patients in the LAMU hospital. As you can see, we have figures there. The questions, they read, construct a sorted stem and leaf diagram for this data using the first 2 digits as the stem. B, calculate the range and the interquartile range. C, comment on and give a possible explanation for the shape of the distribution. And these are the answers to the questions. To construct the stem and leaf plot, we follow the steps written there. We break each stem and leaf. For example, we have 90. So we'll use our 9 as our stem and our 0 as our leaf. We group the numbers by their stems. We then write the leaves in ascending order to correct the stem. And then we also have measures of position. We will use the stem and leaf plots to calculate the measure of position. In percentiles, a patient's blood test score at the 19th percentile means it's better than 90% of the others. The quartiles, we have the upper quartile, the middle quartile, which is the median, and the lower quartile. We organize our data in order in ascending order. We calculate the first quartile as 1/4 times n plus 1, which is 1/4. In this case, we have 30 patients, so we are going to say 30 plus 1, which will give us 7.75 position. Approximately, that is the 18th position. This gives us the position where we can find the figure from the stem and leaf, which will give us 119. On the upper quartile, we calculate it as 3/4 of n plus 1. In this case, our n is the same number, which is the number of the patients plus 1. We calculate it will give us 23.25, which is 25th position, which is the 23rd position, and it gives us 130. From there, we are then able to calculate the interquartile range. The interquartile range measures a variability that shows the spread of the data set. The interquartile range is calculated by subtracting the upper quartile from the lower quartile, which is the Q3 minus the Q1. In this case, our Q3 is 130 and our Q1 is 119, which gives us 11. Now the range measures the total spread of the data set. The range, we calculate it by subtracting the minimum value from the maximum value, which is, in this case, we have 140 minus 90, which will give us 50. On C, it was asking us to give a possible explanation for the presentation of the data. The possible explanation is that the skewness could be attributed to certain patients having mild to moderate hypertension as systolic blood pressure above 130 mmHg is considered elevated per clinical guidelines. Values near 90 mmHg might represent patients with lower than typical pressure due to certain health treatments. Application in different fields. In medicine, statistics helps us sample patients for the drug test. Also, it helps us to measure the recovery times of the patient. In agriculture, crop prediction, yield measured by region and type. It also organizes rainfall and yield data using leaf plots. In finance, analyzing profits across sectors and median stock prices during volatile periods. In government and public policy, it measures social realities, evaluates interventions, and guide decisions that affect millions of citizens. It also helps the governments plan smarter, monitor progress, and ensure accountability in policy execution. In mining, it ensures efficient exploration, safer operations, better resource management, and sustainable environment. In public health, it helps us detect and prevent diseases. And also it improves the population well-being. I'll hand over to my
Good afternoon. My name is Sabrina Yasin, and I'm going to be taking you in the conclusion of the topic of the day, stats and statistics in real life. We can say stats and statistics form the backbone of analytical thinking. They help us make better decisions and think critically. They help us Stats teach us how to organize and relate elements with clarity, whether through union, intersection, or difference, while statistics guide us in interpreting the relationships through data. Together, they offer a structured way to understand complexity, whether we are categorizing symptoms in healthcare, comparing service in business, or building algorithms in computer science. Statistics then further take us, transforming raw numbers into actionable insights through tools like the stem and leaf plots, quartiles, and sampling methods. These techniques are essential in the world of today, where decisions must be backed up by evidence, whether in public health, in finance, or in education. Ultimately, this presentation has shown that statistics and sets are not isolated topics. Rather, they are interconnected tools that empower us to navigate a data-driven world. By embracing both the structure of stats and the insights of statistics, together we form a powerful lens through which to understand the world of today and to contribute to its meaningful progress. That's the end of today's presentation. I would also like to take this opportunity to sincerely thank everyone who joined us for today's presentation. Thank you for your attention and curiosity. This made today's topic an interesting one for all of us present and those who are watching. A heartfelt thanks to all our professors, our teachers and mentors for their guide and support, and my fellow presenters for their dedication and teamwork. I'd like to thank Director Shinundu for her mentor guidance in public health. Math may be full of numbers, but today it is also full of insight, collaboration, and growth. Thank you all once again.
Okay, thank you very
Thank
much
you.
to our lovely presenters. Can we go through one or two slides again? At some point, I thought that you were too fast. Before you could even see what was going on, you had already moved on to the next presentation. There was a slide which was showing things like intersection set, union set, the very first slide. We did kindly tell us what is happening in each and what we are supposed to learn from that. I think we had the union set, intersection set, things like that on that slide. Okay, the very first slide, the very first one where we had, kind of go up. Aha, this one. We didn't get any explanation here. What was happening here? What is the union said? What is, aha.
In the first one, the union says, so we got an example that says A and B, A union B. So it simply says that everything, you add everything that is in A and B, you add them together, it becomes a union. The second one said, yeah, you put them. The second one is the intersection. So the intersection, when they say A intersection B, it means you only get the where A and B are sharing. Yeah, like the middle part, get that part. Then the difference, it's when it says A minus B, it means everything A that does not belong in B. Complement, we have this one that says A complement, meaning everything except A. Clear?
Thank you very much, madam. Clear and straightforward. So when you're making a presentation, don't assume that people know. Cover everything on the presentation. It makes it much more interactive and exciting that way. Otherwise, job well done. Same applies to the stem and leaf. Before I could follow what was happening, the presenter had moved forward. What conclusion do we get from the stem and leaf? The only thing I saw is that you put, is it the first number, her number, which are part of the stem, then lower number is part of the leaf. What we do with that information, I didn't get. I don't know whether we are supposed to relate it to the quartile calculations or what. Kindly shed more light on the stem and leaf.
Okay. You can see the stem and leaf, right?
Uh-huh.
Yes. So we have the stem.
Start by going back to the previous slide. I think they are related to this. Uh-huh.
This one.
So we had these numbers. Before I knew it, the numbers had disappeared. They were separated. Then what came after that, I failed to follow. Okay, we can start from there.
The stem and leaf plots, it organizes numerical data into two parts, which is the stem and the leaf. The stem represents the upper digits, and then the leaf represents the lower digits. And then this is an example. The following data gives the systolic pressure readings in mercury measured for a sample of 8 patients in the Lady Hospital. Those numbers, they are the readings for the blood pressure, for the systolic blood pressure. And then the questions, they go on to say, construct a sorted stem and leaf diagram for this data using the first 2 digits as the stem. At first I say the stem represents the upper digits, but in the question, it can be specified as well. It's specified that we are supposed to use, since we have 90 to 140. So it tells us that the first 2 digits, we have to use them as our stem. And then the last digit, we use it as our leaf. And that is how it's appearing there on in the diagram.
Okay, so for 90, why isn't 9 and 0 part of the stem? You said first 2 digits.
Why isn't what? So, pardon?
90, we have a 9, 10, 11, 12, 13. 10,
Yes.
11, 12, 13, 14, each have 2 digits. So for the first one, why didn't we get 90? Why 9, not 90?
Because we have our stem as the first, as the upper digit, and then the leaf is the lower digit, which is 0. So if we had to write 9 and 0 on the same side, then it was not going to make sense, because the key says stem is the tens, and then it's the tens digit, and then the leaf is the ones digit. Is that clear?
Thank you very much, Madam. Clear.
Thank you.
Ah, wonderful. Do we have any other questions from the people in the audience?
Sorry. Also, just some clarification. On the stem and leaf plots, we can see that if we put the stem and leaf diagram vertically, it will look like a graph. So we can realize that on the stem on top, we have more digits. And then the data is interpreted as the skinniness could not be attributed to certain patients having mild to moderate hypertension, a systolic blood pressure above 130 millimercury is considered elevated by clinical guidelines. Values near 90 millimercury might represent patients with lower than typical blood pressure due to certain health conditions. On the stem and leaf diagram, it shows that most of the patients have their systolic blood pressure falling between the range of 120 to 129. Thank you.
Thank you. Since no one else come in, I've got one more question. We had another illustration where at the hospital, people had multiple complications, some had TB, cholera, syphilis, like that. Then we were asked to determine how many were suffering from one disease only. How did we arrive at that conclusion? That one.
B. So we ended up having 25, 10, and 5 because they're the only ones that are like, alone in malaria, cholera, and pneumonia. So we added them together and we got 40 patients.
Go to the numbers again, like this so many had malaria, this so many had what?
Okay, I'll let my colleague explain more.
So you asked how the numbers were explained and how we got those numbers. So from the general information that we got from the question, we were told that 15 people were suffering from all the diseases. Since they've already given us a total number of the people, if we add the first number that they gave us, they're not going to make sense, which is say that the statistics were wrong. In the question, it says 100 patients were diagnosed with the diseases, 60 malaria, 45 pneumonia, and 40 cholera. 15 had both malaria and pneumonia, 5 had malaria and cholera, and 15 patients had all 3 of the diseases. So using this information, for us to get the number of people who are sick of, let's say, in the intersection of cholera and pneumonia, we subtract from the total, because from the people that were sick of all 3 diseases, these are also the same people who are also sick of cholera and pneumonia. So we subtracted 15, which was the total, from 10, which was sick of cholera and pneumonia. and that's why we have 5 in. So they also asked, how many patients? So the information says how we got the 25 people who are sick of, how we got the 25 people that were sick of malaria. We then added all the intersections new. We then added all the intersections, so that's gonna be 15 plus 5 plus 15, which gave us 35, and we subtracted that from 60, which gave us the total number 60, which gave us 25, which is going to add up to 20, which is going to add up to 60 students. So when we go to cholera, we added the intersections once again, 10 plus 15 plus 5 plus 10. So we could get the correct number. So 10 plus 15 plus 5 minus the total number to find the people who are sick of cholera individually, which gave us 10. Does that answer your question, sir?
It does. Kindly go back to the question again.
Find the number of patients who had exactly one disease.
100 patients, if we add up all the numbers there, are they going to add up to 100?
We add up all the numbers given on the question, they're not going to add up to 100. That's why we ended up subtracting.
Come again.
So from the total number, we have 100. So they
100.
mentioned 60 had malaria. So if we add the numbers here, if we were going to put 60 on malaria, it wasn't going to make sense, because when you add up the number, it's going to go over the total number we're given in the set.
Shouldn't we get 100 at some point when we add up everything?
Yes. So that's why we subtract them from the intersections. As you see, there's a 15. So that when we add all of the numbers, we should get 100.
Ah, wonderful, correct. That is the explanation I was expecting during the presentation.
Everything clear?
Loud and clear, sir.
All right, thank you.
Welcome. The audience, kindly feel free to chip in. It's not a one-man show. Or better still, kindly. Good afternoon, Dennis. How are you?
I'm okay, sir. It's a wonderful presentation. I've learned quite a lot. But considering what has just been presented on the Venn diagram, just out of curiosity, what are some potential pitfalls of this data presentation?
Come again?
What are some of the potential pitfalls of this data presentation? You gave an example of patients where you are scaling patients and presentation of your data in the Venn diagram. I've noticed it's an effective way to present complex data relationships inside of the clear, concise manner. But I wanted to find out what are the potential pitfalls in using the Venn diagram in presentation of your data. I don't know if you've gotten my question. Or rather, how accurate is the information?
So the Venn diagram is supposed to illustrate on how the numbers are adequated respectively, so that you can know how many people are for each case.
Is the question answered?
Dennis, are you happy with the way the question has been answered? Or maybe you can provide more insight by telling us the answer.
No, I don't have the answer. I wanted to find out how accurate is this data, because is it probability sake, or where how accurate is it? 100%? Are there some pitfalls when using this data? Because I noticed when you were saying the data has to be 100 in the Venn diagram, the way we're calculating. Is there a way that you may make a mistake in presentation of data? For example, the patients that were given. So does it mean the person who's supposed to present this data has to be very skillful on the data? Or is it something that can be explained to a layman person and able to present the data? That's my question.
So the purpose of illustrating the data in sets, this is to be more sufficient to help organize the data. Unlike when we do not have sets, and in a way we don't have to categorize the patients, we will not know exactly how many we have and what to do best or what field to work best to help them. This is where sets come in. They provide more light and more organizing way to take situations out.
Thank you very much. Are you happy, Mr. Dennis?
Yes, very happy, sir. Thank you.
Okay, wonderful. Thank you. Any other comment, question, contribution from the audience? Alternatively, you can just simply tell us where you are watching from. I didn't get that. You can kindly put up your hand or you can tell us where you're watching from by typing in the chat. How many are watching from Chalala campus? How many are watching from our Chipata campus? How many are outside Chalala campus? Okay, we have Dennis from Chipata campus. Dennis, how is Chipata campus? Our regards to Mr. Mpundu, the AR, and the rest of the students there. We have Janet Foster, ODL. Madam Janet, which country are you listening from? I know
From
ODL.
Zambia.
From Zambia?
Yes, sir.
Okay, thank you very much. We have Edna Takura watching from Botswana. Oh, Tatenda Takura's mom. Thank you very much, madam. Do you have any comment on the presentation, Madam Edna? Are you happy with what you've seen? Kindly unmute and tell us about your experience. Or you can type. Thank you very much, Madam Edna Takura, all the way from Botswana, for joining us today. Other people, kindly let us know where you're watching from. Do we have any questions for the viewers? Did we prepare any quiz?
No.
Okay, we have Kudawashi Mudechwara from Chalala campus. Thank you very much for joining us, Kudawashi. Okay, I'm very happy I learned a lot from the presentation, as I thought it was just math, but learned of their applications in real life situations. Thank you very much. There are a number of things that I'd overlooked as well, like when selling, you put tomatoes together, onion together. I don't know why I failed to link that is a set on its own. We have Morris watching from Lusaka, Livala South. Thank you very much, Mr. Morris, for joining us. Okay, we come to Madam Junior Kateka. Give us your thoughts on the lovely presentation from our students.
Come again, sir.
Any comment, question, contribution? Are you happy with the presentation?
Thank you, sir. Good afternoon. I would like to just thank my presenters for the wonderful presentation which they put up this afternoon. And thank you, viewers, for being present and for your attentiveness. And thank you to the Dean, Dr. Chiro, for having moderated this presentation. I think I'm very happy with the presentation my students have done. I've put in their best. They might not have been perfect, but I think they're putting their best. Thank you, sir.
Welcome. No, actually, they were perfect. They were near perfect. They did great. Extremely happy with them. I'm happy with the high level presentations. They knew their stuff and they're able to answer all questions. Oh, is that Miss Shinondo back in the studio with us?
Yes,
Ah, okay. Welcome back, madam.
thank you.
Director Shinondo. Do I hand over to you since we're back?
Thank you. Thank you. Otherwise,
Okay.
Dean, excellent job with our questions and answers, and it's always very interactive. Job well done to our presenters. You've done very, very well. This is actually quite a nice group. I would have to submit apologies on behalf of our professorial team as they are attending a burial of one of our senior members of staff, Mr. Magolo. May his soul rest in peace. So we will not have professorial team comments. However, presenters, once again, job well done. Definitely this is being recorded and this will go up on our LAMU YouTube page. So please don't forget to watch, share it with your colleagues, as well as use this for revision, because definitely something will most likely come. So that means we have come to the end of today's virtual pre-medical presentation, mathematics on sets and statistics in real life. Please take note that we have presentations every day of the week. Mondays are dedicated to pre-medical science, Tuesdays preclinical, Wednesdays research, Thursdays clinical grand rounds. That's where our MBCHB students go into the wards and then report back on what they have experienced, as well as Friday, that is for our other faculties, which would be pharmacy, nutrition, dietetics, nursing, and those under health sciences. So we have come to the end of today's presentation. You will find, I cannot stress enough, you'll find this wonderful presentation on our LAMU YouTube page. You'll also find some of their photos posted up on our socials, whether it's Facebook, Instagram, LinkedIn. Congratulations, team. Thank you, everybody, for attending. Enjoy the rest of your day. Thank you.
Thank you. Great presentation.
Can end it.
Um,
see how the vote will be balanced.